Today's target will be factoring polynomials. This will be part one of 2 parts for factoring polynomials. We will cover the basics today, how to set up a factoring problem, and how to use GCFs to start to solve it. By the end of today's lesson, you'll be able to use the area model, and you'll be able to work backwards to find common factors. And you'll use the area model to find factors of a polynomial. We're going to start this video by comparing factoring to multiplication, and that is the exact opposite. What you have here is the example of a multiplication problem. We have 2 factors that, when multiplied together, gives us a single polynomial. So recall from the multiplication video, that when we multiply our factors together, we put the first one down the side, the second one across the top, and then we multiply together to get what's inside. So 3x and 2x would give us 6x squared. 2x and negative 5 would give us negative 10x. 3 and 3x would give us 9x. 3 and negative 5 would give us negative 15. So with a multiplication problem, we start with what's outside. We are given what goes outside. And then the answer is what's inside. So in this case, our answer would be 6x squared minus 10x plus 9x minus 15. With a factoring problem, we start with what's inside. And we have to figure out what goes outside. To do that, we use what's called GCFs. GCF stands for greatest common factor. And the way we approach this is we look at each row and each column, because we have pairs of numbers or pairs of terms. So, for example, our first row pairs 6x squared with negative 10x. From that pair, we look at the GCF, what's common. So the GCF of 6x squared and 10x would be 2x. They're both divisible by 2, and they both have an x. We're going to look at the second row. The GCF of 9x and negative 15 is 3. They're both divisible by 3, but they do not both have an x, so we cannot put an x out with the GCF. Next, we're going to look at our columns. The GCF of 6x squared and 9x would be 3x. They're both divisible by 3, and they share an x. Next up, the last column, we have a GCF of 5, because they're both divisible by 5, but they don't have an x. The only trick here, it's not really a trick, but something to keep in mind, is that if there's a negative in front of that factor, that negative has to come outside. Okay? So it only happens if it's on the outside of the boxes. So what we have here are 2 factors outside the box that make up our answer. Our first factor was 2x and a positive 3. Our second factor was 3x and a negative 5. These would be the factors that multiply together to give us what's inside the box. So we started with the inside. We worked backwards to get what goes outside. Let's look at a second example. This is more typical of what you're going to see on problems on quizzes and tests. You will be given a polynomial. It's your job to fill out the boxes and then use your GCFs to find the factors. So let's start by filling out the boxes. The first one, the x squared term, always goes in the top left. The last one, what we call the constant term, the one without a variable, always goes in the bottom right. Always, every time. Has to work this way. Otherwise, you will not get a correct answer. The 2 in the middle, doesn't really matter where they go. I'm going to put the 15x here in the top right and the 8x in the bottom left. But if you switched those two, it would be perfectly okay. Now that we've set this up, we're going to look at common factors. So our first row, 10x squared and negative 15x, they share a 5 and an x. The next row, 8x and negative 12 are both divisible by 4. So our first factor for this polynomial is 5x plus 4. Now we go to the columns to see what we're going to put on top as our second factor. 10x squared and 8x, both are divisible by 2, and they share an x. And then lastly, we have negative 15x and negative 12. They're both divisible by 3. Remember that if there's a negative here, it has to come outside. So our second factor is 2x minus 3. So here we started with one polynomial, started with what's inside the boxes. We used GCFs to work backwards to get what's outside, and we now have two binomials that when we multiplied them together would give us what we started with. Okay? It is now your turn. I know we only did a couple examples. I want you to do your best. It's okay if you make a mistake. You're going to put these factors, or this polynomial, put its terms into the boxes, make sure you put them in the correct places, and then use GCFs to figure out what goes outside the boxes. Use the previous example. It's the same process. Follow the steps. You can rewind the video if you need to rewatch that previous example to help you out. But do your best, give it a shot, and then press play and check what you have with what I did. Pause the video now. Here's step one. Make sure that you put everything in the correct place. The 6x squared has to go in the top left. The 10 has to go in the bottom right. The 15x and the 4, these two could be switched. So if you had the 15 in the top right and the 4 in the bottom left, that's okay. Your answer will be reversed from what mine is, but that's all right. If you flip them, it means when I go to the next screen, what I have down the side, you're going to have across the top. That's okay. If you did not put everything in the correct place, make a note of it now so you remember to do that when we practice this in class. Here we have our first factor. We're going down the side. We're looking at the pair of 6x squared and 4x. That has a common factor of 2x. And then the 15x and the 10 have a common factor of 5. So our first factor is 2x plus 5. Did you get that right? If not, try to figure out what you did wrong. Make sure you're pairing up the correct numbers, working across the row. Or if you flip the 4 and the 15, you'd be working up and down the columns here. Lastly, we're going to find our second factor. We look at the columns now, so 6x squared and 15x. They're both divisible by 3, and they share an x. So we pull out a 3x from that first column. Next, we have the 4x and the 10. Those are both divisible by 2, so we pull a 2 out. So our second factor would be 3x plus 2. Here we have two factors that when multiplied together would give us 6x squared plus 4x plus 15x plus 10. As always, if you have any questions or concerns or need me to go over any of these examples in more detail, make a note of that so when you come into class, you can get those questions answered while we do our practice.